Using Boolean algebra, simplify the following expression. Let's take a look at this example. First, what we're supposed to do, we have to eliminate this long bar. Okay, how we can eliminate that? By using De Morgan's theorem. In order to break this long bar down, I have to change OR function to the AND function. I'm going to have A, B, not, and A, C, not, or A not, B not, C. Now I'm going to break this bar, the short one this time, right, into two small bars by changing NAND gate to the OR with two inverters, which is simply equivalent to the NAND gate. Next, I have to do the same operation. I have to break the bar above AC. In order to do that, I have to change the function over here, right? The operation from the multiplication to the addition, otherwise from AND to OR. I'm going to have A not or C not, or A not, B not, C. Next, I'm going to multiply these two parentheses by themselves. So that's why I'm going to multiply A times A times C naught or B naught times A naught, B naught, C naught, or A naught, B naught, C. A naught times A naught is just A naught, or let me copy down everything, whatever left, A naught, C naught, or B naught, A naught, or B naught, C naught, or A naught, B naught, C. Now let's take a look. We have A naught over here, A naught, and I have A naught. I'm going to write them down one more time. A naught or A naught, C naught, or I'm going to take from here A naught, B naught, C, and I have also A naught over here, so that's why I'm going to copy this down. B naught, A naught, or B naught, C naught. I'm going to factorize A naught from all these four terms. So I'm going to have A naught, and inside of the parentheses I'm going to have 1 or C naught or B naught C or B naught or B naught C naught. You have to remember that 1 or to anything is going to always give me 1. That's why I'm going to have A naught times 1 or B naught C naught. A naught times 1 is A. That's why my answer is A naught or B naught, C naught.